Alright, what's up? We're going to do a little bit of extra practice with curve sketching. And so we have 7 things that we're trying to find, and we're given a function, so let's get to work. Alright, so first off, I want to find the x and y intercepts. Alright, so easy enough. First of all, in order to find the x-intercepts, I set y equal to 0. And then solve for x, I'll get that x equals 0. And likewise, to find my y-intercept, I'll set x equal to 0. So I'll find that y equals 0 as well. So here are my x and my y-intercepts. Alright, second, I want to find symmetry. So I'm going to plug negative x into my function. So I'll get negative x on top, negative x, I don't know why I did that, negative x squared plus 2 on bottom. So that'll give me negative x over the square root of x squared plus 2. It's as if I multiplied my original function by negative 1. It's the exact opposite, so my function is odd. Alright, that's my symmetry. So I know I have symmetry about the origin. Okay, number 3, I want to find all my asymptotes. Move up here. Okay, so first step, let's take the horizontal limits. So I want to find end behavior, limits to infinity of my function. So first, let's start with the positive one. Right, so remember, this is just x to the first power because it's the square root of x squared. And so my limit to infinity will be 1 over 1. If I take the limit to negative infinity, alright, so I have a negative number divided by, in this case, will always be positive, so I'll get negative 1. Right, so here are my horizontal limits. And now for my vertical asymptote, I set my denominator equal to 0. And I can see right off the bat it's not going to end up well. So I end up with this. So I guess 2i. Okay, so we don't like imaginary numbers, not dealing with it. So no vertical asymptote. But I do have horizontal asymptotes. Alright, and so for step 4, I want to know where my the intervals where my function is increasing and decreasing. I have to find my first derivative. So what I'm going to do is rewrite this as a product of 2 functions. Right, and let's take the derivative. I have to use product rule. So I'll end up with x squared plus 2 to the negative 1/2 plus x times negative 1/2 x squared plus 2 to the negative 3/2 times 2x. Alright, let's combine these. So I have 1 over the square root of x squared plus 2 plus, looks like, actually, the minus, I have 2x squared on top. So that's the 2x times x is 2x squared. I have a 2 on bottom, and then I guess x squared plus 2 to the 3/2 on bottom. And you know what? In the same vein, I'm going to write this as to the 1/2. Alright, I need to get a common denominator, so I'm going to multiply this by 2x squared plus 2 on top and bottom. Alright, so our bases are the same. I'm going to add the exponent. So 1 plus 1/2 is going to be 3/2. That's why I picked that. So I end up with 2x squared plus 4 minus 2x squared over 2 times x squared plus 2 to the 3/2 power. Those will cancel. So I end up with 4 over 2 times x squared plus 2 to the 3/2 power. Okay, so this is just like up here, the situation. I had no vertical asymptotes. So this tells me that I'm going to have no critical points. Alright, so I have x squared plus 2 on bottom. This is always going to be positive. And there's going to be no critical points. So because there's no critical points, that means that my function is always going to be increasing or decreasing. That's what we call a monotonic function. It's strictly increasing or decreasing. In this case, my first derivative is always positive. right? And I know that because any number I plug in for x, I'm going to get a positive number back. So it's always going to be positive, meaning my first derivative is always, sorry, my original function is always increasing. All right, so now we got that out of the way. Next, I want to find relative extrema. Well, that's kind of a problem because I have no critical numbers, so no extrema. Okay, number 6, I want to find where I want to find my concavity. So if we take the derivative again, I just have it here, so I'll show you. You'll have to trust me on this. The 5 half power. Okay, so I took the derivative again. This is what I ended up getting after simplifying. All right, so this is my second derivative. And so this time I will have a potential inflection point because of my numerator here. So x equals 0 is a potential inflection point. I'm going to test it. So I do a number line, 0, and I'm going to test points to the left and to the right of this. So anything to the left, I plug into my second derivative, I get a positive number back because the negative times the negative is positive. And anything to the right, negative times negative, sorry, anything to the right, anything to the right is going to be, this is all positive stuff, so positive times negative will be negative. So that means I'm concave up, concave down here. All right, and then the last thing, inflection points. So because the sign changed about 0, I know x equals 0 is a point of inflection. All right, then they want me to try to sketch the graph. So it's very similar to the one we did in our last notes. My horizontal asymptotes are 1 and -1. I pass through the origin, and it looks kind of like a cube root function. All right, that's it. See y'all later.